Hi guys, welcome to lesson 4.03, Introduction to Proofs and Counterexamples. So first you have your little warm-up, and this is from our previous lesson. I want you to identify the type of relationship between your angles. I'm telling you that these lines are parallel with my notation. Find x based on the type of angles and their relationship. Pause the video, set up your equations and solve. Come back and check your answers. You should have had that these are corresponding angles. They are in the same position on the different intersections. They're both on the top right. They are congruent. So I set them equal to each other and solve for x. On number 2, I have same side of the transversal, and they're interior inside the parallel lines. So they are same side interiors, and they are supplementary. They add together to equal 180. You solve for x equals 65. Okay, we're going to look at some types of proofs today. A paragraph proof, you can read it. You don't have a textbook, but I've got one at the end. We're going to talk about it. This is not what we focus on. We focus on two-column proofs. And this is the most common type of proof in geometry, and we're going to work through some of those together today. This Ask Dr. Math is a great little website to go to if you get a little confused and you want some extra insight. Now, when two-column proofs, we have a column for our statements and a column for our reasons. And it's usually set up like this on a little T-chart. And we want to number our statements and number our reasons. This helps us line things up and make sure that we're reading them correctly. Okay, so this is a little example. It's kind of convoluted, so bear with me. There's no diagram. Normally you do have one, but I can help you with this one even if we don't have a diagram. Fill in the blanks to complete the proof of the reflexive property of congruence. Reflexive is like reflection. That means things are congruent to themselves. So we have our first statement. Number 1, A is an angle. Okay, that's just a statement that's been given to us. We call that given information. Step 2, the measure of angle A equals the measure of angle A. So things that are equal to themselves, that would be the reflexive property of equality. Reflexive property of equality. Now to step 3, when things are equal to each other, they are congruent, because that's the definition of congruency. When things are congruent means to have the same measure. So this is going to be definition of congruency. Okay. So a postulate is a statement that is accepted without proof in mathematics. And a theorem is a statement that has been proven to be true. It's proved true. So we talk about postulates and theorems. In some higher order or higher level, maybe college geometry classes, there's hundreds of them. You would have to state postulate, whatever, 2 points of whatever, and write out the whole postulate, or theorem, whatever. You're not going to have to do that in this class. If you get confused between postulates and theorems, it's okay. I'm looking to see if your reasoning is sound. So now this is the way we set up our two-column proofs. You write a statement, and then you have to tell me why are you allowed to make that statement. It's almost like court. So you make a statement, and then your reason is why are you allowed to make that statement. Kind of like court. Okay, here's a bunch of different things that you're going to be using in your proofs. Okay, these are, I'm going to kind of section them off for you. So now let's look at this in 3 different ways. Over here, this would be your given. So in the given information, they would say something like B is the midpoint of AC. Okay, that's your given information. with that given information, you can make this statement. So in the red here, we have our statements. And then finally, they'll say, well, why can you make that statement that AB is congruent to BC? Well, it's the definition of midpoint. B is the midpoint of AC, so I know by the definition of midpoint, that's my reason, that I can make that statement. Bisecting an angle, you can say that the two pieces are congruent to each other by definition of angle bisector. If you're given that something forms a linear pair, you know that their measures equal 180 by the linear pair postulate. If you're told two angles are complementary, you know their measures equal 90 degrees based on the definition of complementary. This is just some more of the same list. Kind of separate them out for you. You want to keep referring back to these. These are kind of a little cheat sheet for when you're doing proofs. And if you are given information like those things, then that's kind of like a clue, okay, that I'm going to make those statements and give those reasons. So this would be your given stuff. Again, these would be your statements. And these would be your reasons. Okay, again, this is just some more information that you would be using to set up your proofs. You might be given a diagram of something like this, and notice that all of these are parallel lines. You have to pay attention to the notation. When you're given a figure, always look for different notation. These would be statements you could make. And these would be your reasons. Let's look at a couple examples. I'm going to go back quickly. So if I'm given the figure, I've got a segment DEF, or really DF, and E is on it. I know that DE plus EF equals the whole DF. I could make that statement based on the segment addition postulate. If I've given a figure such as this, I've got parallel lines on a transversal, I know that 1 and 2 are supplementary because they are same side interior angles. I could say 2 and 3 are also supplementary, but that would be because of the linear pair postulate. Just a few more. This could be your given. These could be your statements. And these would be your reasons. So this is an important one right here. If A is congruent to B and B is congruent to C, then A is congruent to C. We call this the transitive property of congruence. Transitive meaning you can move one to the other, moves. And if these were equal signs, we would say transitive property of equality. But basically, I have two different things equal to the same thing. So I've got A and C, which are two different things, equal to the same thing. So they are equal to each other. If you have two different things equal to the same thing, then they are equal to each other, and that would be the transitive property of whatever. You might have a situation where you've got congruent angles, and then you know this equals 90, and so you could substitute in angle 2 for angle 1. That would be your substitution property. So let's put it all together and look at a couple of little proofs. Now, your statement. Your first statement here, number 1, is almost always your given. I mean, like always. The thing of it is you may be given more than one statement, and it's okay to have given broken up throughout your proof, or you can list it all at first. But right here, I'm going to write that OB, segment OB, bisects angle TOY. I like to go, okay, that's my given information, and I go ahead and make some markings on my diagram. Because, oh, I know that bisect means it cuts into 2 pieces, so this is my given. And then your last statement is what you're trying to prove. This is always your last statement, always. Last statement. So I'm going to say angle 1 equals angle 2, and that is by definition of bisects. As if they give you something bisects, you're going to have definition of bisects in your proof. If they give you something as a midpoint, you're going to have definition of midpoint in your proof. Okay, let's take a look at this one. Now these numbers, let's fix these quickly. This is not a good setup. I'm going to put angle 2 here, angle 1 here. We're going to leave angle 3 there. Just get rid of my little angle 2 right here. Okay, now we're having to prove that n is parallel to m. This is where we're going to use a converse or a counter example. So angle 1 and angle 2 are supplementary. Okay, that was part of my given information. I'm not using same side interior angles because I don't know that those are parallel lines yet. I just know I have 2 lines and a transversal. All right, angle 1 and angle 3 are a linear pair. There's my linear pair. And I know that by definition of linear pair. Two adjacent angles on the same line. Now the linear pair postulate lets me know that angle 1 and angle 3 are supplementary. Now I'm doing that because I see down here that says congruent supplements there. So I got to come up with some sort of congruent supplements. Angle 1 and 2 are up here listed as supplementary. So now I've got angle 1 and angle 3 are supplementary. Okay, so now I can say that I've got 2 different things supplementary to the same thing. So I know that they are congruent to each other by the congruent supplements theorem. Now angle 2 and angle 3 are corresponding angles. And since I have corresponding angles that are congruent, that makes my lines parallel. This is the converse of corresponding angles theorem. Corresponding angle theorem says if your lines are parallel, then your corresponding angles are congruent. The converse would be if your corresponding angles are congruent, then your lines are parallel. Okay, these are a couple of examples of proofs. They've already got them written for you. A and B are supplementary, and the measure of angle of A is 45 degrees. That is your given information. So I know if I add the 2 together, that's the equals 180 definition of supplementaries. Okay, I'm substituting the 45 degrees there. And then my subtraction property of equality, if I subtract 45 degrees from both sides, it's not shown. It's just what I did to get from step 3 to step 4, and I'm allowed to make the statement because of the subtraction property of equality. Okay, here's another example for you. This, whoops, right here, that you can go through with. See, notice that they've talked about midpoint here, and you've got definition of midpoint in your proof. All right, so here is a kind of a weird one. We're given the xy. xy is congruent to xy, reflects a property, and definition of congruent segments. Here, you've got your answers right here to these